So you've got WebAssembly. It lets you run these massive desktop-style apps right in your browser. And then you've got Docker, which lets you run pretty much any app anywhere. Now, on their own, they're super powerful. But what happens when you put them together? Well, they might just be the future of software. Let's break it all down.
Okay, let's just start with a really big idea here. Imagine you could run something huge like Photoshop or Figma, but you don't have to download anything, no long installation process. You just open your web browser and boom, it's right there running instantly.
Now, this isn't some far-off future tech. It's actually possible right now thanks to something called WebAssembly or, WASM for short. The easiest way to think about it is like a new universal language for the web. It lets developers take really high-performance code, stuff written in C++ or Rust, and just run it, blazing fast, right there in your browser.
All right, so to really get a feel for how this works, let's do something simple. We're going to take a classic Hello World program, the first thing every coder writes. But this one's written in C, and we're going to see what it takes to get it running online.
So here's our code. Super simple. Hello World. In the old days, right, you'd compile this thing, and it would become a native application. Something that runs directly on your Windows machine or your Mac.
But with WASM, things get interesting. We've got two paths we can take. The first path is the traditional one. We use a compiler, we get a native app. The second path, though, this is where the magic happens. We use a special compiler that takes that exact same C code and turns it into a WASM module. It also spits out a little bit of JavaScript glue code that helps the browser understand how to run it.
And check this out. The result is, well, it's pretty incredible. The same logic from the same C code is now running inside the browser, and you can see the output right there on the web page. This just shows you how powerful WASM is. I mean, it completely opens up a new world for what's possible with web apps. Okay, but here's where it gets really interesting. WASM's power isn't just about the browser. The real promise, the big idea, is its ability to run anywhere. You see, a WASM binary is totally platform neutral. Once you compile your code, that one file can run on any machine that has a WASM runtime. It doesn't matter if it's Windows, Mac, or Linux, or if it's an Intel chip or an ARM chip. It's all made possible by something called WASM. That's the WebAssembly System Interface. It's like a secure translator that lets the WASM code talk to the operating system. So what does that really mean? It means the exact same file can run on your Windows desktop and on a tiny Linux server in the cloud. No changes needed. That's a huge deal. Now, this whole idea of package once, run anywhere, it probably sounds familiar, right? It's trying to solve a super common, super annoying problem that I'm willing to bet a lot of you developers have run into.
Yeah, you know the one. The classic line, but it works on my machine. We've all said it. You spend forever on some code. It's perfect on your laptop, and then you send it to your colleague, and it just completely falls apart on their computer.
And why does this happen? Well, because getting code to run on different machines has always been a pain. You have to install the right compiler, get the exact versions of all the libraries, mess around with system path variables. It's just this fragile, complicated dance that's super prone to errors and version conflicts. A total nightmare. This is the exact problem Docker was built to solve. Docker lets you take your application, bundle it up with all its libraries and dependencies, the whole shebang, into one single package. We call that a container. And that container is a self-contained little world that guarantees your code will run exactly the same every single time, no matter whose machine it's on. Okay, so we've got Docker and we've got WASM, and both of them are making this big promise of portability, but they go about it in pretty different ways. So let's put them side by side and really see what's going on. So if you look at how they're built, you can see the core difference right away. Docker is basically creating a mini, virtualized operating system. A Docker container has your app, sure, but it also has all the libraries and system files it needs, all running on top of the Docker engine. WASM, on the other hand, is much more lightweight. The WASM module is literally just your compiled application code. That's it, and it runs inside a super lean WASM runtime. And this table here, it really nails the key differences. Docker images are bigger, sometimes a lot bigger, because they're packing that whole file system. WASM modules? They're tiny, because it's just your app's binary. And here's the kicker. Docker gives you portability, for sure, but you still need a different image for an Intel machine versus an ARM machine. WASM is, well, it's truly universal. That one single binary file will run on any OS and any CPU, period. So after seeing all that, the big question is probably popping into your head, which one should I use? I mean, is WASM going to make Docker obsolete? But here's the thing.
The answer isn't either or. It's not a showdown between the two. The real power comes when you stop thinking of them as competitors and start thinking about how to use them together.
Let's take a serverless function, for example. You could write the really heavy computational part of your logic in something super fast, like Rust. Then you compile that down into a tiny, lightning-fast WASM module. And then you use Docker to wrap up that little WASM module into a standard, easy-to-deploy container. Now you've got the best of both worlds, ready to ship to AWS Lambda, Google Cloud Functions, wherever.
And the workflow is actually super simple. Step 1, compile your code to a WASM module. Step 2, write a really basic Docker file that just copies that module into an image and tells the container to run it. After that, it's just business as usual for Docker. You build the image, you push it to a registry, and you deploy it. What you end up with is the mind-blowing performance and tiny size of WASM, all packaged up and delivered using the reliable, familiar tools of the Docker ecosystem.
So yeah, it's not about one replacing the other. It's about two incredibly powerful technologies forming an alliance. This hybrid approach lets you build apps that are not only super performant, but also unbelievably portable. It's really the best of both worlds.
All right, so let's boil it all down. What are the key takeaways here? WebAssembly gives you a universal, secure, and super lightweight binary. Docker gives you a universal way to package and run things. They're not fighting for the same spot. They're actually solving the portability problem at two different levels. They complement each other perfectly.
And this powerful combination leaves us with one last big question to think about. As we all look for better, faster, more secure ways to build and ship our software, could this be it? Is this hybrid model, a tiny, powerful WASM core wrapped inside a standard Docker container, is that the future of how we deploy applications?